Previous class we have discussed about this topic, right? Object in using the presentation in this class, because it's a review of the previous topics. Just we'll have again just review, and I'll share this also. Please practice at your this because classes, while up to functions it's okay. It is like other programming language. From the classes and objects, you should concentrate more. So I'll share this. Please try to implement that. If you already know, there is no need of doing learning anything. So coming to the class and objects, class is like a blueprint, right? So I'll increase the size. Okay, I hope it is visible. This is a blueprint for creating the objects. Okay, and uh, it defines properties like variables and methods. Like here, a class person is there, where we are trying to define a method called greet, where in that we'll print hello. Okay, and for this person we can create object by simply the object name p1 and person in the parentheses. Okay, so if we click on p1 dot greet, the output is, see, p1 for this object we're calling this method. Okay, where it will output the hello. Okay, and we also discussed about the constructor. So constructor is a default method which should be initialized when we are creating an object. So this special method which should be run when an object is created. So in the P1, when it is created itself, and if you want to run a method when it is created by default, here we have called it. But by default, if you want to run some method, then you can use this init method, okay, which we call as a constructor. So what happens? This will be called in this line itself. P1 is equal to person of, in this line itself, this will be called. So here we are not calling any specifically some method, but if you want to execute something while creating the object, you can use this init method. Right. So here the self and name is the variable, and self dot name is equal to instant variable. That is the uh, method we have created in terms of the constructor. So here when we call this for the constructor, we need to send some variable. What is that? Some string which will be stored in the name. So here we are sending alias, which will be, if you execute this, what happens? Automatically, this li will store, alias will be storing in the name of name. And when we greet it, it is used. So in the greet, I can see, hello, my name is self.name, which we are implementing. So the name which is created at the time of creation of the object will be used here. So then we were discussing about the two important things like instance variables and class variables. Instance variable will be created
Yeah.
with the objects.
Sir, excuse
Uh,
me, sir.
uh,
Uh, many people are asking to hide the sharing bar. Yes, sir. Yes, sir.
okay. So anyway, this is a repetition of the previous session. Okay, repetition. That's the reason we are going fast. So so we are talking about the instance variable versus class variable. Instance variables are unique to each object. That means here you can see we have created a class variable called species. And here the name is instant variable. Okay. So when you are creating an object dog of Rex, okay. So for this D1, Rex will be the for the D1, and the body will be for the D2. But in the both the cases, we can use the variable called species, because it is common to all the objects which is created, which are using this class. This we call as class variable. This class variable shared among all instances. Instance variable are only for the object. So we'll pass those variables for that object itself. Okay. So in the same manner, instant methods are there, class methods are there. Okay. So class instant methods, or when we create a object based on that, those methods are used. Okay, they are very specific to those objects. And class methods are represented with tagged with the when we define a class method, they should be tagged with @class method. Okay, so this @class method, once we declare it, then when we name it as @class method, then if we're defining something, then this is called as, like here, default fields is called as class method, which is common to all instances. Okay, so you can call this method directly using the class name itself. You need, okay, and we can also, so that we call as class methods and instance methods. Okay, instance methods are very specific to the particular object instance data, and class methods are common to all all uh, all objects which is created. Then another important topic we have to discuss here in the object oriented program is how we implement principles of OOP. Like, what are the basic principles of the OOP? When we talk about the object oriented programming, we will talk about the inheritance, we will talk about the polymorphism, we will talk about the uh, abstraction. These are the main three concepts which object oriented program. These are the main properties of the object oriented programming. So inheritance is the method property of object oriented programming, where will inherit the features or attributes of the senior parent class, right? So here an animal is a class which is parent. We are using this class in the dog. So what happens? This dog will by default get all the methods which are specified in the animal. So if you create an object for the dog, automatically you can call which is declared in its parent method. So here dog is a class. You are initializing or using the class of animal, okay, as a parent class. So here in this, you have created a variable called d. Okay, so for the dog, and you can also call the method which is in the animal. Okay, so that we call as inheritance. Okay, we'll discuss further while creating the objects, and while we are using our real-time examples, like in robotics or health industry, how we can use them. But you need to know this concept. Then we are talking about the polymorphism. So polymorphism is a method where same method acts will be having different meaning based on the signatures. So class cat is, you can see, it sounds self. Cat is a class. Cat, here we have created with the method called sound, which prints a meow. Okay, and dog is another class which is prints as bark. Both have the same method. You can see sound. Say we have created a method which where make sound, which includes this animal. Okay, so what happens? This animal, when we use it, when we use for this cat, it, and we are sending that, if it's here in this make sound, this in the place of animal, we are sending the any object of this. right? Like dog or cat. Okay, this is the variable where we are creating in this variable any object. If you are sending the C object, the cat object C, then it will sound the same method will be sounding as meow, right? And if you are sending the D object, which is created for the dog, the same method will be reflecting with the D. So here in this method, okay, we have created a method using the function where we are sending a variable, which is an object, and this variable works in different ways based on the classes we are sending as an object, right? So here first we are sending C, it will give the output as Mio, and when we are sending D, it will output as bar, right? So this method is an outer method, right? So this method works in different manner based on the variable or object we are sending, right? So so that we call as same method. If it works differently for different classes, then we call as polymorphism. Then we are talking about the encapsulation. So encapsulation is protecting some variables which can be used only by this class or only by this object, not from the externals. Normally, any variable you can get from the outside, right? If it is a public. But if you are using a private, you cannot access the variables from the outside. You can only access from the inside one, right? To create any data, to make any data private, okay, what you have to do, you have to simply use the double underscore, self dot double underscore. What it is making? It is making this variable to private, okay? So this variable cannot be used outside of the class, which can be used only by the functions which are in the class. Okay. So that we call as encapsulation. A little more example understanding of this encapsulation. Encapsulation means hiding the internal details of a class, okay, and provided the controlled access to it. Data is kept safe, so external code cannot change it in unexpected ways. So access is given only through the methods like getters and setters. So when you're creating any project, all of you know what is getter and setters functions, right? So we'll use these functions only to get the value or edit the value of the a particular class, right? So we cannot because directly we cannot access those numbers. Like it's a locker. So balance is the money is inside the locker, which is to be private. And you cannot just open it. You must have an official access mechanism to deposit or withdraw. So here, class account is there. Init is the constructor, self balance is a private variable. Okay. And in the deposit, what we are doing, self comma amount. If amount is greater than 0, whatever amount you're creating as a deposit should be added to the balance. And to get the balance, what you're doing, you're using the get balance return self underscore balance. This private variable you are mentioning. Okay. So here the double underscore makes the balance variable to private. It cannot be accessed directly like if you're using dot double underscore balance variable dot and double underscore balance, you cannot access it. Okay, so controlled access are like getters and setters. So here you are using the get balance is a getter, right? Setter is a deposit method. So which you are using to set the balance or increase the balance. Okay. So here, say 100, we are creating an object for account. and A is a variable and you're setting a 100 value, then automatically this method will be called and which will update the content of this under double underscore balance, which is a private method. Okay. So we will discuss, we'll what we call, we'll practice those also. I think encapsulation is important. Not only encapsulation, all the object oriented concepts are important and you need to practice them. Otherwise, when it is required really, programming up to functions is different. But using the object oriented programming is different. So that will, I'll show you executing those examples also. Okay. So, so this with getters, so here, as I said, setter is a method, like deposit is a method which we call as a setting, and get withdraw is also a method which is the setting, and get balance is the, you're directly getting the value of a particular private variable. Okay. So this we call as encapsulation. Encapsulation is concept where we talk about private variables and a level of we are hiding the information and which can be accessed only through the methods of the particular object. Then we are talking about set. Okay, setters is okay. Abstraction. Abstraction is hiding the internal details to show essentials using the abstract based classes. Okay. Abstract ABC we call them, right? So when you talk about ABC and or someone asks you about what is ABC, abstract based classes, you have to talk based on the context. So from a we can use this we can import ABC from ABC. Okay. And we can create an abstract method using the @abstract method. So as you know, class methods can be created using the @class method, right? So here abstract methods can be created using the @abstract methods. Okay. So this is, while we are creating say this area, uh, it is creating an area. Okay. And for a circle, shape variable will be sending object of this shape. Okay. Then it will be updating based on the radius. Okay. And when we create area, when we create this circle, it will be updated with the radius. Okay. And this area will be calculated based on the radius. Okay. For the circle, we can calculate the area using the radius, right? So this is the unmethod. This is the constructor where this circle is a class which is having the parent class of area. Okay. So that is the abstraction, hiding of the info. Directly we are not using this area. Instead, based on the subclass, we are using that. So abstraction means hiding the implementation details and showing only the necessary things. We need not in Python. We achieve this using the ABC, capital ABC. Okay. And abstract methods. So the user of the class doesn't need to know how the method works internally. They just call it. Okay. So like a drive car, we use the steering wheel, accelerator, and brakes. We don't know exactly how this engine or a transmission works. So here for the circle, okay, we are only sending the phi value, right? So this phi value, based on this circle object, it will be printing. Okay. Though it is defined in the its parent class as the common. right? So from the here you can see in our example, shape is an abstract class and abstract method is area, where you're simply saying pass. Pass means no implementation here, only area should be calculated. That rule we are specifying that some these should be there. So whenever say you are creating a class for a car, every but government rule says it should have the accelerator, brake, and steering. So that is the abstract method they are specifying. Every company will have usage in different manners. Some may use the electrical, some may unique hydraulic, some may use different methods of using accelerators and brakes. But it should be kept at the leg, right? So there will be predefined rule which should be common to everyone. They will be kept as an abstract, and implementation can be done individually. Okay, so that we call as abstract class. Okay, and the concrete class is here circle, where circle inherits from the shape. Okay, so you should be remembering this abstract and abstract class and concrete class as well. Okay, so in summary, encapsulation protects the data and abstraction hides the implementation details and focus on what, not how and all. So what should be there and not what should cannot be there, and how it should be providing what should be done, not how it can be done. It you don't specify how it can, need not to specify how it can be done, but what should be done, it will be specifying. So here area should be calculated, that is specified, and in the subclasses circle will be acting in different manner, and it will implement the area in its way, in its own way. And if it is a square, a square or a rectangle, it will work in a different manner, right? But both should be implementing the area, right? So that we call as abstraction. Okay, so this is the notes. Let me share. Please practice those things. Anyways, today we are in a hurry to practice as per the syllabus. We need to discuss the NumPy pandas also. We'll discuss that. Uh, you want me to execute this examples which we have discussed right now, or we can go to the NumPys we discussed. Then we also discussed about the instance variables and class variables, instance methods and class methods. Okay. And we also discussed about the inheritance, the concept of inheritance. Okay. So in the next session, while repetition goes, we'll discuss where we use this inheritance in our examples like healthcare as well as the um, this robotics. And we also discussed about the polymorphism. So inheritance is a method in a property where the class can be inherited to the child, and the methods which are in this parent class will be used in can be used in the child class object. Okay, and polymorphism is where same methods can behave in different for different classes, that we have discussed. Then we have also discussed about encapsulation, how private variables are created using the double underscore. And we also discussed about the what is encapsulation, and we also discussed about the abstractions, how we can in the abstracts ABC, what we have to do, we have to specify to the child classes these things are compulsory. How you can do it, that is on your own. So that we specify in terms of the abstract base class. Okay, so then that is the concepts which you have to do. I hope I have given you the document. Please download it and you can use it. Then let me unshare. I will go to the numpys. NumPy before going to the NumPy on it. So before going to the NumPy or pandas, mostly we'll use NumPy can be used anywhere, but the next thing we have to do is data clean. Okay, so data cleaning, then we will go for the actual what we call the actual methods like implementing after cleaning the data, then only we will go with using different libraries like NumPy, Pandas, uh, Scip, Matplotlib, and TensorFlow. All whatever libraries we use first, that implementation always starts after cleaning the data based on our requirement. So whenever in while we are doing ML or AI and any project, first whatever data we are getting, that should be made ready for next process. Okay, so in this sessions, along with the NumPy and Pandas, we'll have a data. Tomorrow we'll have in depth, little bit depth knowledge of the data cleaning. Okay, so what is data cleaning and what is the importance of the data cleaning? So how do we handle the missing data? Some data is not there. Then how we can handle them before pushing that to the this NumPy or Pandas or any libraries? How do we remove the duplicates? If you're removing the duplicates, is it anything? Do we are we are missing anything while removing the duplicates? So that should be checked because the duplicate may not be duplicate. That may be duplicate in the simple the column set we are using, but it may be having another further information. So another extra columns may be there. Then how do we handle the outliers? How do we perform the type conversions for cleaning the data? So if some data which is to be numerical, it is in the string. Then how we recognize them? Automation. How the automation recognizes it and it will convert it. Then string operation and standardization, the scaling of the features, okay, downwards and upwards, upscale and downscale. And how do we do the normalization and encoding of the categorical data. So all these things we'll be discussing in the next class. So because though we started the NumPy and Pandas, but before application of the any libraries, we should be knowing what is data cleaning. Okay. So that we'll parallelly discuss, we'll implement this cleaning also using different methods and all. Okay. So parallelly both will be discussed. Uh, then today we'll start with the NumPy. Okay. So what is the NumPy arrays and what are the Python lists? What are the array creation methods, array indexing and slicing, array operations, the mathematical and statistical broadcasting, those things we'll be discussing today. We'll start today and it takes 1 week. It will take for you discussing NumPy and Pandas, okay, and reshaping and flattering arrays. And we'll also discuss what is Pandas, what is a series, and what is a data frame. Okay, in Python we have few data structures, right? Again, when we are going for the Pandas, what extra data structures we can use it? How do we import the data for cleaning or using any data? We have to import, right? That we can do using the Pandas. How we can do from the different sources. So live data store source may be different, and CSV, Excel, and SQL data. And how do we import? What is the code we write for unstructured data? Okay, and data exploration, like the info describe, and how do we index and select the data from, say, we have 1 lakh records. How do you select or index some cells or some row of data which from the 1 lakh rows? And filtering and conditional selection, how it can be done using the pandas, and how we can do by using the group by and aggregation, how we can do using the pandas, how we can do merging and joining and concatenations, and handling the missing data in pandas. So this step always the numpy is a little bit more. Normally, it is used after the after also. But normally, these are the basic libraries which starts pandas. It starts with the data. Okay, so anywhere after the requirement analysis, our projects always start while going for the after design and everything. Always project starts with the data, getting the data, cleaning the data, using the data. So while we are making it ready, obviously we have to use these pandas as well as the NumPy as a basic libraries which are normally used for doing all these processes. Okay, and NumPy, moreover, it can be used anywhere for any even in the algorithms or functions which we are importing. So there, normally we use the NumPy also. Anyways, we'll discuss this. So that these are the topics which we are going to discuss in this next coming lectures. Today we'll discuss a little bit NumPys. Okay, then we'll go to the pandas, which is also important, and parallelly these three cleaning all these things we'll do. Okay, so NumPy, why we go, uh, why we need to use this library? Okay, so before going that, what is this NumPy, SciPy, as well as the Matplotlib? Okay, which uh, these actually provide a MATLAB like functionality in the Python. So, MATLAB is again a tool which is mostly used for the research and doing the implementing many. It is a paid one, and it is mostly when many people use this MATLAB for in the data science as well as the ML and all. Okay, R also, R is again that tool, MATLAB, and R. These are the different frameworks and tools which can be used for research and doing the manipulation, calculations, and implementing different functions. Many methods are also there, predefined methods are also there, and you can also write on your own. So it mostly the NumPy or SciPy or Matplotlib also provide the relevant functionality which is up to MATLAB, right? MATLAB is a paid one, So obviously the paid one always comes with the next level of product features, next level of availability and on, right? But these are the open sources, right? NumPy, SciPy, Matplotlib are the open sources. But if you know well, we can implement the functionality which is provided in the MATLAB using these things. Okay, mainly NumPy is a library, okay, or a framework. It's a library which has the features like multi-dimensional errors, matrices. So most of the research, everything nowadays is used using the matrices, right? So it is a fast numerical. It has an option for fast numerical calculations on the matrix, and high level math functions can be implemented using the NumPy. If you are using the NumPy for simple multiplication and all, normally the NumPy is used to do some operations, to implement some operations for matrices. Mostly it is concentrating on the matrix calculation. So, say simple example, say you want to perform 1,000 into 1,000 matrix multiplication. All of you know in matrix multiplications, right? Matrix additions, matrix multiplications, all of you know, right? So this is a high level computation, right? So Python, if you are using the matrix multiplication, what you have to do is you have to use in the Python, you have to use the triple loop, right? So while if you're writing a matrix multiplication program, it takes a triple loop. Normally, it will take greater than 10 minutes to execute 1,000 into 1,000 matrix multiplication, right? So I know all of you know that 1,000 to 1,000, 1,000 rows into 1,000 rows to 1,000 column. N into M is 1,000 into 1,000. So that if you're doing N into M multiplication with another matrix, normally if you're having high-end system, it will take more greater than 10 minutes. It also depends on the processor as well as it also depends on the server. But if you're doing that the same, which takes greater than 10 minutes, it will be done in a 0.03 seconds by NumPy. That's how fast it can implement. So we'll be discussing the latest Python, latest versions of NumPy and SciPy. Okay, NumPy mostly we talk about arrays, shaping and transpositions, and doing the mathematical operations, indexing and slicing, and broadcasting. The NumPy is only mostly used for these things. Okay, shaping and transformation, working on arrays, mathematical operations can be done, and it uses for indexing and slicing of the data and broadcasting. So in the arrays, okay, structure a list of numbers are like vectors, matrices, images, tensors, and convnets. Okay, convnets. Okay, so vectors and matrices, okay, these are the vectors which have multiple values instead of one. Then the matrices, n into n matrices, right? N into m matrices. So, and images, okay, which we call, again, if you convert that into the data, which is having high scalar or high dimensional data, right? Then tensors and convolutional nets. So, which are mostly like, if you observe, these are the basic basis for implementing all NumPy data. Okay. So combinedly at the convolutional net, which connects with everything, okay, and works with, gives the output by taking the data from different networks, right? So the basis is matrices, right? So we'll start everywhere whenever we're using the NumPy. We'll start the NumPy, we'll import the NumPy, and we'll save that in a variable called NP. Okay, so this NP is a variable which is loaded with the NumPy, which we import. So that is the statement. Whenever we use any library, we'll use that using the import NumPy as NP. Sometimes if, when you're using Anaconda or any Python, normally sometimes some libraries are not by default. In that case, you have to install them. Then you can use the import option, right? So here, this is an array. This is np dot array. Using that, we are creating a variable. Okay, and the data type is float, and this is the value we are initializing. and we are storing that in the and variable a. Okay, we can use the print a and dimension to get the dimensions, and a dot shape is to get the shape, and a dot type and data type is to get the data type. Okay, so arrays can have any number of dimensions, including zero. So if it is a zero dimension, we call it as a scalar, right? So arrays are typed, okay, and arrays are dense, like each element. So here, the data can be float 64 or float 32 or int 64 or int a. So these arrays can be specified in terms of the type also. And arrays are dense. Each element of the array exists and has the same type. Okay. So there we call them as a dense. Okay. So arrays can be we can create using the arrays creation can be done using the np dot once. Empty mp is the object, right, of the numpy. So using the ones, and you can using if you use np dot ones, we can use np dot zeros. We can use to create the ones and zeros matrices or arrays. Okay. So like that, these are the different basic methods using you can create the arrays. Okay. So if we create np ones 3 comma 5, data type is equal to np of float 32. Okay, then it will create ones of 3 rows and five columns array. Okay, so like that, it will be creating. If I create np of zeros, it will be creating zeros array. Okay, so by simply by giving a simple and using the object and the method, ones method and zeros method and arrange method and concatenate method, using that we can create different arrays. Then using this also arrange, we can create from 34 to 37, right? So these values we can create using this array we can create using the arrange. And see here, one is a is equal to ones we have created, b is equal to zeros we have created, and we can concatenate both. We can combine the both arrays using the concatenate method. And we can also create as type using this using the this concat. After that, we can create an as type also. This is a concatenate method where we are creating using the access is equal to 1. Okay. And we can also use the as type and zeros like and ones like also same in the methods. These are the different methods. So using the random, say we want to create a random matrix, we can create using the random. Okay, so we should be very careful. We cannot, so while combining the different arrays, we cannot combine the arrays of different shapes. Okay, it will throw the error. And it should be dense, and we should not check. We should check while you are using the arrays in the this numpys. Okay. So the shaping, what is the size? See, shape is 3 comma 2. We can reshape them. Okay. And when one shape, we can convert that into the reshape. That means the rows and columns also can be changed. All right. So like that, we can transpose the current matrices with using the transposition. Okay. And we can save and load the data also using the save jet as well as the load methods. Okay. So like that, we can use this np object or an numpy in different contexts. Okay. Like images are 3D arrays, like width, height, and channels will be there. Normally, common image format will be RGB, height, width into RGB. Okay, so this data can be also used using the NumPy as well as this SciPy and OpenCV also. This will discuss in the further once we go and do start doing some NumPy examples. Okay, before going in depth, just we'll have a few practice of this NumPys. Okay, let me share my screen practice session. Just hold on. We go further, you will not be understanding. So let me start with the practice on NumPys. So you can see 10 to 55, we have created an array where difference is 5. Okay, that is the use of array. So you can create a sequence by make telling the difference. If it is not told, it will be a sequential. Okay, one difference will be 1. If you're saying 2, two difference will be there from one number to the other. It starts from the 10, mostly it ends with the n minus 1. This is what an array of. Then another example, let me give. So you can see it is a random number. Here it is the arrange is a sequential order. This random is to generate random number from 80 to 181. Okay, so we created an array where the values are a random numbers from 80 to 181. Okay, so that's how we have created. Okay, using the random. And few more examples, like we can also use this NP for indexing or slicing, right? So we can get slicing means, so in the total data, to get part of the data, we use the slice method. Even the indexing also. Indexing is normally, how do we index a matrix? Using the n and m values, or a cell value and row value, right? So that we can do using the indexing, and we can also do that using do the part of the data using the slicing methods. So in this, you can see the array is 120, 125, 180, 130, right? So first three, if you want to get first three, then you can simply use the BP in the bracket colon 3. Then you'll get the first three. If you want to get the last two, like 100 and 115, then you use the minus 2. And if you want to get the alternative data, we use the double colon and 2. Right? So like that, from an array, if you want, you can use this indexing. Colon 3 means first 3. Minus 2 means last 2. And colon 2 means alternatives. Okay, and that is one for array. If it is the array of 3 rows, right? We want to get the second row. Simply you will be using the 1. If you want to get the first column, simply you can use the colon and 0. Colon comma 0. And if you want to use the sixth position value, you can simply say 1 and 2. So this is the first row and second column, right? 0, 1, 2. Second column, 0, 1. So that is the first column, right? First column.